Hey geometry friends, here we are in section A4. We are looking at trigonometry. And so what is trigonometry? That's one of the questions that we should be answering as we look at our new vocabulary. Trigonometry is the study of the measure of triangle lengths or sides. Particularly when we talk about trigonometry, we generally start off by discussing the right triangle and the relationship between the lengths of a right triangle, right, given the fact that you know a particular angle. I am going to refer to this little angle here, let me make the pen a little smaller, as x degrees. So if I'm standing at angle x, I can talk about the side opposite x as the opposite side. If I'm standing at angle x, I can refer to this side as, well, the hypotenuse, right? Because it is indeed the hypotenuse. So let me call it the hypotenuse. And this side over here, it's also next to x. So instead of calling it the hypotenuse again or some leg, I'm going to call it the adjacent because adjacent means next to, and it's the side next to x. You with me? All right. So when I'm standing at this angle, there's specific relationships that I can talk about if I'm talking about the ratio within the ratios within this triangle. Remember what a ratio is? It's the comparison of two numbers. So I can say that the sine function or the relationship that I'm talking about when I talk about sine, which is all of these are the major trigonometric let me see, put it over here. The three major or more in, not more important, but more common trigonometric ratios. There's three other ones that are not as common. So the sine would be, if I stand at this angle, the relationship of the opposite over the hypotenuse. All right. And so it is just a trigonometric ratio. The cosine is considered the adjacent over the hypotenuse. And the tangent is considered the opposite over the adjacent. And I'm going to put super long equal signs there and write opposite over adjacent. And so these words, sine, cosine, tangent, refer specifically to these ratios when you are standing at a particular angle. And that's going to be important in a few minutes. We'll talk about that. So, well, let me talk about it now. So if I were to think about the sine, I would say the sine of an angle, sine of angle x. Notice the abbreviation for sine is SIN. It's not sin, it's sine here. So the sine of x is equal to the number, the opposite, whatever the opposite value or the length here over the hypotenuse, that value will be the sine of that angle. And if you think about this, if you can think about this in a larger sense, it doesn't matter how big or the size of the right triangle that I draw here, right? Because all of these triangles that I'm drawing with this same x angle will have a certain relationship with this black triangle. And even if I draw them really small, right? If I keep drawing triangles that are either smaller than or larger than this right triangle with this same angle and all of them being right angles, they will all be similar triangles. Therefore, the opposite over opposite over hypotenuse or opposite over this hypotenuse or opposite over this will all be equal. So if I plug it into my calculator, I know we're going with a lot here, stay with me. If I plug sine of x into my calculator, and x being some angle, the ratio that I get will be for any right triangle that has that angle, and if I'm standing at that angle, kind of, sort of. So we will write sine of x is equal to some number here. Now, the inverse sine, as with the inverse of cosine and tangent and all of those, the inverse of those means instead of me starting off with an angle to figure out the ratio, I can start off with a ratio. So the inverse sine is written like this. Sine inverse of the opposite over hypotenuse, and you wouldn't have opposite over hypotenuse, you'd have some number, is equal to some angle. All right, so inverse functions, if you remember from algebra, this is more algebra too, but if you've ever had inverse functions, basically inverse functions means if you start off with x and you lead to y, then the inverse will start you off with a y value and lead to x. So it kind of just flip-flops. Stay with me. I know it seems crazy, but it'll make sense soon. So inverse sine, inverse cosine, inverse tangent would be doing the exact same thing. If I know the cosine of an angle, I can figure out the angle by doing the inverse cosine. If I know the tangent of an angle, I can figure out what that angle is by doing the inverse tangent. Let's get to a couple more bits of information that might be helpful. So trigonometric ratios, we've got the word trigonometry comes from two Greek words, trigon meaning triangle and metron meaning measure. Study of trigonometry involves triangle measurement. We talked about that. Trigonometric ratio is a ratio of the lengths of two sides of a right triangle. So what I like about this little example here is that we have three different right triangles that have a degree measure of 35, and therefore we know that these three triangles are similar, right? We can go back to some of the definitions of similar triangles. However, the cool thing here is that by these triangles being similar, so we also have equivalence when we look at segment AC to AB and segment FH to FG and segment JL to JK. And because all of these ratios are equal, we can name each of these ratios, as we've done with sine, cosine, tangent. We can name these ratios particular things. So this next graphic is mad helpful in trying to think about what these ratios refer to. So if I'm standing at angle A, here's angle A, the opposite side would be A and the hypotenuse would be C. And if you remember, sine is opposite over hypotenuse. So the sine of A, let me stay at angle A for a minute, the sine of angle A is opposite over hypotenuse, or A over C. If I change my perspective and I go to angle B, then the opposite changes to B and the hypotenuse stays C. So B over C is the ratio I will be talking about. So it's not just enough to say you're talking about some right angle triangle. You need to know exactly what angle you're talking about in order to determine the sine, cosine, and tangent. The little mnemonic device that teachers all over the world use is sine is opposite over hypotenuse. So cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, right? And so the mnemonic device really goes so ka toa. And I've heard teachers tell little long stories about, people speaking in the night and hearing voices and so ka toa. Whatever you need to do to memorize this, memorize this. You can make up a little story if you like. All right. So now that we've gotten through that, let's see if we can practice with some of these these functions, these relationships. So I'm going to write SOHCAHTOA right here at the top. And I'm doing this because it's really a helpful thing to be able to, anytime you need to figure out some ratios, just to have it like right there. So here's example 1. Express each ratio as a fraction and as a decimal to the nearest hundredth. So sine of P. So if I'm standing at angle P, sine is opposite over hypotenuse. That's going to be sine is going to be 15 over 17. So there it is as a fraction. So if I were to write it as a decimal, I get my handy calculator and basically just divide 15 by 17. And I get that my answer is, oh, lost my calculator. Let's bring it back. Come on, calcul. All right, so my answer is going to be 0.88. What did it say, to the nearest hundredth? So this is the hundredths place, so 0.88. So approximately 0.88. And I'm going to do that for all of these. What's the cosine of P? So if I'm standing at P, cosine is adjacent over hypotenuse. So that would be 8 over 17. The tangent of P, if I'll do the decimals in a minute. Tangent of P, if I'm standing at P and I'm thinking about tangent, that's opposite over adjacent. So that would be 15 over 8. The sine of Q, so I'm standing here, sine is opposite over hypotenuse. So that's 8 over 17. The cosine of Q, if I'm standing over here at Q, cosine is adjacent over hypotenuse. So that's going to be 15 over 17. And then finally tangent of Q. Where's tangent of Q? Q is over here. Tangent is opposite over, no it's not, yes it is, it's opposite over adjacent, TOA, my bad, and that's going to be 8 over 15. And so we can find the decimal values by using a calculator, and you would get these values here. Not too bad, right? All right, let's try something else. Here in example 2, we're going to use, okay, so here in example 2, we're going to use a special right triangle to express the tangent of 30 degrees as a fraction and as a decimal to the nearest hundredth. So the special right triangle, if we're talking about, if we're talking about a 30-degree special right triangle, we should be talking about a 30, 60, 90 right triangle, right? So I'm going to draw one of those bad boys as best I can. And there we go, and I'll label this side 30 degrees and this side 60. And so what I'll do is I'll say, well, let's put down what we know. I know that if this is 30 degrees, opposite 30 degrees will be the smallest side. So let's call that S. And then I know that the hypotenuse is always double. You remember these rules from like yesterday. So S, 2S for that part, and remember my 1, 2, 3 thing, and then S root 3. Okay, so this is the relationship between the sides. We don't know what the side lengths are, but this is what the relationship is. Now it says use with this special right triangle to express the tangent of 30 degrees. Well, we're hanging out at this angle. Tangent we remember to be TOA, right? So tangent is equal to opposite over adjacent. And then what we need to do at this point is apply what we know to what we have. So opposite of 30, because that's the angle where I'm standing at, is S. And the adjacent, it wouldn't be this guy because this is the hypotenuse. The adjacent is the other one that makes 30 degrees. So that's going to be S root 3. All right. So technically we're done, but technically we're not. So watch this. So the tangent of 30 degrees, if I were to go grab a calculator, I would get the equivalent of some number over some number times root 3. I'm hoping you see that these guys cancel each other out, and basically I have 1 over root 3. You remember that old story? Mathematicians don't like to divide by radicals, so we're going to multiply by a deliberate, gourmet, tailored one to our situation, which I will highlight and make it like a 1 there. And so I'm writing an equivalent value to the tangent of 30. 1 over root 3 times root 3 over root 3 is root 3 over 3. And so if we use a calculator, like say our handy dandy Desmos calculator, we get an approximation of 0.577. So I will write that down as my answer, 0.577, which is exactly square root of 3 over 3. But for us, we're going to use 0.577. So check this out. Let me see if I can do this over here in Desmos. So let me just do this. The tangent of 30 degrees looks a little bit different here. And the reason why is because the way Desmos is doing this, and I'm doing this for a reason, is because you need to make sure your calculator, whatever device you're using, is in degrees. And notice when I switched it to degrees, we got that the tangent of 30 degrees was 0.577. Radians is a different way of measuring angles that refers to the circumference of a circle and its ratio to the radius. It's not that hard. I'm making it sound crazy, and it's kind of a neat thing to use. But when you use a calculator and you're thinking through, you're doing anything with trigonometry, you have to know exactly where you stand. With that in mind, let's take a look at some other stuff. So we have this problem and we're reaching the end of our time together. So I'm going to read the problem and I'll probably answer it in the next video. Sorry for 2 parts, but we got to do what we got to do. So we have a hiker, and this hiker is hiking up a slope that's about 5 degrees. After traveling a horizontal distance of 100 feet, we want to know what's the displacement, the vertical displacement of the hiker, and we also want to know how long the hiker actually traveled on the path. So that vertical displacement, or that change in vertical position, would be x, and the displacement along the path is going to be y. We'll work on that the next time we get together. See you soon.